Welcome to Los Angeles Data Platform. Today we have a session by John Sterrett, and the session is Make Your SQL Server Queries Go Faster. Welcome to all the attendees, and thank you, John, for spending your precious time with us. Our sponsor is our nonprofit, which is called Data Driven Technologies. And I guess that is all. You can join us or follow us using LA Data Platform hashtag on Facebook, Twitter, LinkedIn, Instagram, and YouTube. And on YouTube, you obviously will be able to see most of the sessions that we recorded and the speaker agreed to publish. Again, welcome to Los Angeles Data Platform. John, it's all yours.
All righty, well, thank you for the introduction, Steve. All right, so I'll turn my webcam on so everyone can see me and see that I'm live in here. It's a pleasure to be able to present with you guys here and kind of go over a lot of tips I've learned throughout several years of focusing real deep into performance tuning. So, a lot of people might touch indexes, but one area where I definitely have strived in my career is being able to refactor code. When I say refactor code, that means actually take code that runs and gets you results that you expect, but might be a little bit slow, and being able to rewrite that code a little bit different to get you the same results, but make it be a lot more optimizer friendly or run faster. So,
John?
Yes.
Are you planning to share your screen?
Yep, I am.
Okay.
Yes.
So that's a friendly reminder.
Yep, nope, definitely appreciate it, Steve.
No problem.
So, yeah, a little bit about me. I'm a Microsoft certified trainer. I focus on SQL Server. I own and run a consultant company based in Austin where we focus on making data go as fast as possible among anything else that's SQL Server related. I've written a book and I love SQL Server. In fact, there's a photo of my bookshelf there of all kinds of various different books focused on SQL Server. And yes, I actually have gone through every single one of those over there. But
you're still not sharing your screen.
Oh, I thought I was. Okay. Oh, apologize for that. There we.
Yep, I see SQL Server Profiler.
All right.
Okay, perfect.
Yeah, no, apologize about that. So yeah, here's just a little bit about me. Any way you can get a hold of me if you have any questions. So as a presenter, I also love to learn. So one thing I will do is make all the code available for everyone. So that way, if you actually want to go through these demos on your own, you're more than welcome to. And if you have any questions, feel free to reach out to me as well. But yeah, as I mentioned, Microsoft certified trainer there, which is kind of the highest you can get in the Microsoft certification area. Been certified through all the Microsoft database solution experts categories that don't exist anymore. Like I said here, wrote a book as well back in 2014 and definitely love SQL Server. So if you have any questions, definitely reach out. I'll have that slide here at the end as well for us, but also here, we're going to focus on what are the goals for tonight here. So we're going to go over some of the very basics of benchmarking queries here. So what do I typically do whenever I start to go through after I've identified, a query or set of queries that need to be tuned, how I kind of walk through that process there, because I think that's key to have a good foundation as you're starting. With that, we're going to cover the following, what I like to classify as anti-patterns, and that's just a nice friendly way of saying, here are patterns that a lot of developers love to use. I started as a developer. I learned how to tune and got started into tuning by making my own code, what I would say, crappy code a little less crappy here. So here's a lot of those patterns that even I went through myself. So first one we'll go through as a warm-up here for everyone. So be a great regardless of what skill level you have here, kind of going over benchmarking and what I would call over-indexing. From there, we're going to drive into sargability and some reasons why you may have an index, but your code isn't able to utilize it to do seeks, and you're having to scan, read every single row for those indexes. We'll touch up here a little bit on inline table value functions here versus table functions. We're going to jump in and show for anyone who has utilized SQL Server 2019 how inlining UTF functions can change the results there and whether that's good or bad for you. We'll definitely go through that. We'll go through multi-statement table value functions versus inline table value functions, table variables versus temp tables. CTEs gone wrong. You know, you hear a lot of people say CTEs are evil. It's not necessarily true. It's usually the way how people use them that might not be ideal. And then we'll wrap up here with implicit conversions, what I call the typical kitchen sink reporting query, where basically you build a stored procedure with a bunch of parameters and, you know, only one of them might be used or all 100 of them, an example, might be used. So we'll kind of talk about how you can get better performance in those scenarios. And then finally, what I like to call running totals. So with that, we'll go ahead and go to our first question here. So I'm just curious, how many people are utilizing SQL Server 2017 today? If you are, go ahead and give us a thumb up on the icon there. And yes, if you don't see it, there should be like a smile face with a hand up. All right. So I see Elena definitely is. Wow, it doesn't look like many others. Okay, Karen had a hand up. All righty. How about SQL Server 2017 along with 19? Do we get any more hands raised there? Okay. Awesome. We got a few more. I'm actually, I'm real curious. We should maybe keep this going. How many people are on 16 or higher? All right, so that got a few more. We're probably about, I would say, close to 50% there. Okay, awesome. Well, yeah, like I said, a lot of the stuff we're going to go over. There's ways to rewrite it that make it faster for all the additions there, but we will highlight on some of the newer stuff for 17 and 19 as well there. All right, well, I appreciate everyone there for our first interactive question. And with that, we'll go back on over to the slide deck.
I think there is, again, there was a question if this is 2019 or Azure, but I think Azure just means latest and greatest because you cannot even choose, right?
Well, yeah, I mean, so Azure kind of has its own builds out there for Azure SQL Database, Azure Managed Instance that usually will include everything that you have there for 2019 and some newer stuff in there. So yeah, I mean, that would count as well for 19. All right. So as I mentioned with 17 and 19, we're going to cover this kind of 4 interesting new feature areas that helps a bit and sometimes does not help with taking your code and kind of doing some of the refactoring for you. And so we're definitely going to highlight on both, especially by seeing how many people are still on 2016 or lower. Well, we're definitely going to focus on how you do this before, but we're also going to show you some changes that you can expect to see or to look for with 17 and 19 as well. And yeah, so here's just a diagram from Books Online. It just kind of shows you all the various different new intelligent query processing things that are added and where they were added, whether it's 17 or 19 here. So yeah, we'll definitely highlight over table variable deferred computation, the inline scalar UDFs. We'll definitely go over adaptive joins as well there and memory grant feedback. So we'll pretty much hit all of these here as we go through some of those patterns. And so with that, we're going to go ahead and jump in over to our demos here. So I have this whole thing up. We'll get to why that's there in a bit. It's not running. There'll be one little example here where profiler or extended events can actually be a very good friend, which we'll get to in a second. So we're going to start off here with what I call the very basics beginning. So a couple things people always ask me whenever I'm helping them with tuning is, like how do you go through and benchmark a query? So we're going to go through that process here. And there's a couple of things that I go through and do. First of all, I like to have an isolated environment. When I say isolated, this means definitely not production, where I can go through and make changes and be able to easily measure them and not have to worry about other people or other processes using the same data here. So everything we do here is non-production. It's done in what I would call just, explained as an isolated environment. And some of the reasons why is I always want to go for worst case. Whenever you look at an execution plan, which we're about to get into, you're never going to know how many data pages you need to references in memory. So I always like to start off from what I call worst case scenario, which is assuming and forcing that you have nothing and that everything needs to get read in from disk. And the way how I do that is through 3 commands here. So the first one here, checkpoint, what this does is it takes any of your database pages there and it checkpoints them. So if you have any dirty buffers there, they can end up becoming clean buffers. The next thing over there is we're going to actually drop and remove our clean buffers and actually free up our proc cache, which means all of our execution plans won't be in memory and all of our data pages there won't be in memory.
John, there is a
Yes.
question. How to choose columns for non-clustered index?
Great question. I love that question because we're actually this first thing is going to jump right into an example of that. So I'm going to be able to answer that here as we go along. So I always love questions that get answered here in the demos. It lets me know I'm doing something right. So once again, these 3 commands are something that you do not want to do in production because taking all of your data pages in memory and all of your plans and throwing them in a trash can so you have to regenerate or repull them from disk is going to cause a lot of I/O. So once again, this is something I'm going to do in an isolated environment, which I have here. The other thing I'm going to do is I'm going to go ahead and use what is known as an actual execution plan here. And that's by clicking on this icon in Management Studio. And what this is going to do is let me understand how SQL Server Optimizer builds a good enough plan so it can get one quickly to help us get our data. So those are 3 things I'm going to look at doing. The other here, the third one, is I want to be able to look at metrics here. So if you go to your query options in Management Studio, you can go to Advanced here and you can either type this in. I'm lazy and I typically go through and click it in here. But this same thing is you could type it in some of the demos here. You'll see I'll have it typed out, but there's no difference. Basically what this will do is it'll let me how many logical pages were read, which means pages that are in memory, versus physical, which is ones that had to come from disk, go into memory first before we can use them. And same thing for CPU and time used. So just a little bonus information here. While I'm throwing every plan away, if you had just like one you wanted to get rid of, you can actually throw the plan guide in here as a parameter, and that would get rid of that one single plan here. But as I showed you, here's me instead of using the interface, just using T-SQL to turn on my statistics for I/O and time. And so the very first thing I'm going to do here is we have 2 queries we're going to run. And before we run them, I want to see what everyone thinks that's watching us here. Which one of these queries do you think would go faster? So go ahead and give me a raise your hand if you think it's the first one up top here, or give me a thumb up if you think it's going to be our bottom one down here. All right, I'm going to pull over to the chat here so I can see.
Just to make sure, raise your hand if first one is faster, thumbs up if second one is faster. Correct?
Correct, yes. All right, so Karen has a thumb up, which is great. And then I think someone threw a question in the chat. All right, someone says same performance for both.
So some people saying depends, which is...
Yep, which actually it is a great answer. So here we don't necessarily know for multiple reasons. We haven't looked at indexing. I know someone asked questions about indexing. So let's go ahead and take a look here. So I turned on my execution plan here, and we're going to run these here side by side, and I'm going to show you how. It's a good way to see how I would go about benchmarking these at a very basic, easy level. So one of the first things I might look at here is if we look at our queries, they're both look exactly the same. So when I say exactly the same here, our cost when you run these two side by side are 50-50. And we have the same operators here. So we're doing what's known as a clustered index scan, which means I am going to look through and go through every single page inside of the B tree for the table here. And so I'm doing this on both of those, regardless of which columns I am selecting here. So what I'm going to do here now is raise up. So this is us looking at our set statistics IO. And there's a couple of things that we definitely want to highlight here. The first one is if you're comparing a query with changes, you definitely want to hope you get the same results back. So quick, easy way to first look at that, make sure you have same row count here. I actually on my blog here, which I can throw in here a little later, I have a way where you can actually put your results in temp tables and easily compare. So if any column of your result set was different, you would instantly know. That's kind of how I do a detailed process of that. But at least first glance, I want to make sure that I have the same rows back here. And then looking at these queries here, we're going to go ahead and take a look at logical reads here. Because once again, we don't know what pages are actually in memory or not. And so here to scan the whole person's table here, you can see that we're doing about 3,800 reads here. And so this is how long it takes for our query to start to finish, and that's how much our CPU time is. And so from an IO perspective, there's absolutely no difference here, right? We have our 3,816 reads here off our one scan. The only difference here is what data comes back through the network to be presented over there. So hopefully that's kind of a good start to looking at execution plans and kind of understand the basics of how I would go about benchmarking a query. So next part here. So now who thinks that our second query here would go faster than our first one here because we have a filter? Go ahead and do a thumb up here if you think that this would be faster. If you think the bottom would be faster than the top one.
Can we know how many rows are inside person.person? In total.
Total? We could. So I have some thumb ups there, and I know someone asked a question about can we see how many rows are there? I'm going to show you a nice little easy, lazy way to do that quickly without having to do a whole lot of I/O. It's kind of a nice little cheat way, but you, Steve, you asked how many rows. I'm going to go look at the statistics for my primary key to get roughly your answer here. And so if we zoom in on this without actually having to do like a select count or go to any data pages here, I can see on the 16th, which is pretty recent, we have about 20,000 rows in there.
Interesting. Thank you.
So once again, we don't know indexing here, but let's go ahead and run these here. And we're going to go ahead and take a look here. And we're going to see that even with our filter, we have this nice little missing index hint that we may or may not want to use, which we're going to talk about in a bit here, but we're still scanning. And the reason why there, which in the scan means looking at every single row, so we still have the same IO here, even though we have our filter. And so if you're curious, you want to know what indexes you have, you can use the shortcut Alt F1. There's a lot of scripts. You could SB help is actually what the shortcut does here. And here I'm going to zoom in just to show you that we only have two indexes. The clustered index is on business entity and the other one is on row GUID here. So we don't have any indexes at all that would help for our filter here. So someone mentioned if there was an index there, yes. So, and that's exactly what we're going to do here. So the very first step is, so we know we have about 3,000 or 3,800 logical reads here. We're going to add an index for our filter here. All right, and then we're going to run that same query on the bottom. And this time we're going to get different results. And so now you can see here, we are doing an index seek, which means instead of before we were kind of scanning through the whole tree, now we're able to go directly towards exactly the data that we need here. So the one thing to note here, though, this is helping us for our predicate. We have a nested loop join, which means for every row in here, we're going to go do what's down here. And so here we have a key lookup, and it also, if you look here at your cost, that's 99% of kind of what's going on here. So let's go ahead. We looked at our plan. So when we go look here, we're definitely going to see some good things. For example,
this is actually really interesting because you're selecting from one table, but it's still doing a join.
It's going back to, so on every index you have, even the non-clustered ones, it's going to have the primary key. So you could go back, or I'm sorry, not the primary key, but the clustered index there, so it can go back and get columns that would be needed there. So that's exactly what you're seeing there, Steve. So we are
all I'm saying is I normally don't see a join operator used that I'm selecting from one table.
Oh, well, you would
but
in any
I understand
the
key lookup. This is what's going to happen. Yeah.
Yeah. And so if you're curious here and you wanted to know exactly easily, okay, so what was needed, our output list will show us what was selected but not included in our index. So even though already we made this from an IO standpoint 10 times better, we went from 3,000 to 300 here. If you wanted to make this the best possible, what you could do is rebuild this index here, but include the actual select column as an included column here. So this tags the data along for selectivity purposes there, but it wouldn't seek across filtering for first name here. And so if you're kind of curious difference between clustered and non-clustered, clustered's how the table is formatted. It's basically including every single column because that's how the data is persisted for you. But here, so when we run this query again, we're going to see one operator instead of that nested loop. And so this is kind of your ideal sweet spot, if you can, to where there's only one single operator going on here. We can see that we're seeking through our B tree there, and we're going straight to our select there. So in this case, we went all the way from 300 here down to 4 logical reads here. And so the question that happens here is, well, what happens now when we add another column here? And when this happens, we go back to our key lookup here because we're selecting a column that wasn't included in our index. And so what I see a lot of people do out in the real world here is go ahead and create another index for this. And we're going to go ahead and talk about this. Here's that's going through building our index here, and then here's actually filtering. So we get back to our ideal best case scenario, but now we have two indexes that are pretty much basically the same. And if you're curious to know if you have any of those, you can easily look through querying over here. And see that we just created and added a duplicate index there. So even what I'm going to do here is now if we select 100 times, so basically I'm running this statement here. I'm going to go ahead and turn off my actual execution plan to make this go faster. We can look at our index usage over time too here. So we'll see our two indexes here. I've ran this 101 times here. And now even if I run both queries, we'll see that the same index gets used. Oh, let me go ahead and turn back on that execution plan here. So, and if we hover over that, you will see here as I zoom in that we have the number 2 index there for both of those. So this is a case where I see a lot of indexes there because people are so driven and focus on individual queries that there's other queries that can be impacted, or the optimizer, as there's more indexes that are added, can struggle to get you an optimized execution plan there. So for this here, you can go ahead and drop. Our other one here, we'll double check here just to show you that yes, we're still using the same index there because we included the one that, we kept the one that included first name and middle name. So that way we can use the same index as we were using before for both of those there. So that's kind of first little example there going over indexes. Other things to note there is for your statistics of your index, only the first column is factored in there. So if you're using multiple columns and you always start with one column, you tend to have a lot of statistics based off that one column, which can lead to bad execution plans as well.
John?
Yes.
Quick question. And this is something that I heard. I don't know if this is true or not, but does the include columns needs to match the order of the select columns?
So the question was, does the include order have to match the order in the select columns? And yes. No, it does not need to.
So regardless of the order, it still will either perform good or bad?
Correct. Yeah, it'll all be tied in there for selectivity.
Okay.
All right, so let's go. We're going to now look at use cases here where we have indexes that we're expecting to use for seeks, but we're going to see that we're actually not able to. And ironically, I was dealing, the code was a lot bigger than what we're seeing here, but just, Steve, an hour before we were actually starting this meeting, I was actually running into this exact scenario here where we want to search and find something, and we're using a wildcard because we don't exactly know where in this column that data might be here. And so when you do this, unfortunately, SQL Server is not going to be able to seek through your index here. And so you're going to actually have to go through and scan. And if you look at the tree here, the reason why is because when you start with a wildcard, then it really has no idea, okay, what can we skip? Where over here, when we have a starting point, this knows that I can actually seek through over there. So we'll look at these two side by side here. You know, same results. But because of that change there to where we got rid of the first wildcard here, we're actually able to seek our index here. And you can see that the cost here is 3%. This is 97. And even if we look at our IO as well, you know, we can see we go from 106 there to 3. So as your data, the other thing to note when you're doing these scans here, as your table gets bigger and has more data, the worse this is going to perform because it's going to have to scan it through every single row that you have. So another example here is a use case where you add a function and you wrap it around a column here. So this is going to give you a similar effect here, which we'll talk about here. So here, once again, I'll go ahead and highlight here, because we're using this function here, it has to do a substring of your actual data here before it can actually do the filtering here. Where over here, since we know we're only looking at the first character and we're making sure that it starts with S, we could just go ahead and rewrite this to where we use a like operator here and seek through. So similar aspects with dates here. So here's an example I see very frequently where someone is basically trying to strip out the actual day of a date time or date time to field. And this will cause you to scan across here. Where here, if you cast it from date time to date, it's actually able to help you with this here and do the conversion for you to help. So same thing here. If you wanted for this date, another way that you could do this here would be to actually just do a AND statement where you look at the beginning and ending of records for that day. And you see this will actually even get you a little cleaner here than what we saw over up here. I mean, results from an IO perspective are pretty similar. So if we go look at our IO, in this case, same amount of reads for both of those use cases there. And then one thing I always just want to double point out here is if you do betweens. Oh, someone asked a question too that I see in the chat. If the operator was on the right side, so that's a great question here. And we'll have an example of that coming up here. But the goal there is, yeah, you definitely want to keep them if you need them away from your column and use them on your predicate filter, which we'll see in a little bit here. So this one, you'll see our row count is actually different, and that's because when you do between, it actually includes both. So if you had any records here that didn't have time for that date, those would be included as well. And so here's an example here where we're looking at year. So same thing, scan here versus a seek. And so you can see the IO difference is quite a bit over there. And then here's that example that was asked in chat about, well, what if we do it on the other side here? And the answer here perfectly is, because we're not restricting and forcing to do anything on our column here, and we're just doing it on a predicate filter here, this will allow you to go through and seek. All right, so here we can see our scan, not so good, going across, versus our seek here, going straight through what we want. And so next pattern we'll see in one of our last demos, I'm going to go through a much bigger example of this, but I see a lot of cases where people basically want to filter on scenarios where, you know, if the data has a value, then let's filter based on it. But if the data is null, well, then let's make a 1-to-1 equal so that way we basically don't filter on there. And so here we're going through and we're doing scan there. Where here we're going to use is null, which kind of gets you the same thing, but the big difference here is coalesce is an ANSI-SQL function where is null is a T-SQL function. And so T-SQL here, the optimizer is able to know that and kind of redo this for you, which I'll show you kind of a nice little example here. When we look at our execution plan here, and we look at our predicate here, we can see how it was able to basically go ahead and do the operation filter there for you. And so we have implicit conversions as another reason why your queries might not be sarkable. Okay, and I see a question too in the chat window from someone saying, do you recommend table hint with no lock on a table? So no lock basically would allow for dirty reads. It's a technique that some people use to get data maybe a little bit quicker to not cause blocking from other things that need to access the data that you're trying to pull. It's something I definitely don't recommend using without extreme knowledge of the fact that you might have dirty reads in there, which basically would mean that you might have scenarios where you saw data that never actually got committed there. So yeah, I mean, it's kind of going outside of the talk here. I can talk a lot more about isolation patterns and things you may want to consider. But yeah, no, for that, I definitely want to avoid using no lock wherever possible. But here's just looking at two examples here of basically we have a nvarchar and a varchar here, and we're joining to the opposite. So some ORMs are famous for this, where, for example, even though you have, an nvarchar, it may still pass in a varchar and vice versa here. And here in this example, you're going to see the similar thing here where we're scanning when we're going from varchar to nvarchar. And in case you're curious, how do you know that? It's because you have the n here in front of that and typecasting that there as well. So yeah, we'll go into implicit conversions more here, but as we get a little later, but that's just kind of showing you some basic different reasons why you might not be able to seek on an index. It's a famous interview question I love to ask whenever I'm helping companies interview for DBAs, is basically what are something that might prevent you from being able to seek on an index that exists and forces you to scan. We just went through multiple different acceptable answers there for that. And so here we're going to go now and actually start digging deeper into our, what I classify as anti-patterns over here, on how we're going to continue to rewrite code here. So I'm going to use a copy of my AdventureWorks that I have. I'm making the compatibility mode 2019. So what I'm going to do here, so in 2019, there is functionality to help a lot of cases for scalar functions, which we're going to go through here. I'm going to start on turning this off, especially so everyone here can see how this works if you don't have 19. So if you have 17 all the way to 2005, you'd get a similar experience here. And so this is the demo where I actually need Profiler. And what I'm going to do here is I want to profile this one single session here. So I'm going to go ahead and clear this out. You can use extended events for this as well. But just to be a little quicker, I like profile. And you can see here I've filtered this so it's only going to catch and go after my session that I have open here. And the reason why I'm going to do this is we're going to see that scalar functions are known as, one of the ways I like to define them, is a silent performance killer. And you'll see exactly why here when we go through the example here. So in this case here, I have a pretty simple function where I'm going to pass in a product ID. And all I'm trying to do is just figure out, okay, what was the max quantity that we ever had for that product ID? So very simple, not a whole lot of stuff in here. So we'll have that there. And once again, to start from the worst case example here, I'm going to go ahead and throw all my pages and execution plans in the trash can and start empty. And also you saw here that we disabled up top for the database. But here I'm also just showing you as well how you could disable this via a query hint as well. So if this was enabled, I could go ahead and use this query hint to disable and not use scalar UDF inlining for this statement here. So I'm going to run this, and this is going to run for a little while. The reason why I have Profiler here is because you're going to see that we have row by row processing. And so what this means is every single row here that we're using, and in this case here, I'm going across the whole products table here. For every single row in here, I'm going to put in the product ID to this function and get its result, and we're going to refer to it over here as max quantity here. So this ran, it took about 17 seconds to complete, has 504 rows. So remember, we're taking our products table, all the results here, and one by one executing this function. So this function just ran 504 times. If we had 1,000,000 rows in this table, it would have ran 1,000,000 times. And remember, on this function here, we're focusing on the sales order detailed enlarged table here. And you see that it's inside of this function here. So let's go look at our execution plan. And so I call this a silent performance killer because the very first thing you should notice if you know the function is the table in it is nowhere referenced in here. All we have is our scan across our products table. At the same point here, if we go look at our IO, you might get real confused because again, we don't have that sales order detail enlarged table in here at all. We only see what looks outstanding as 4 logical reads from the product table because it's not that big. There's only 504 rows in it. But this thing took a whopping 16 seconds to run. And so if I just looked at this by itself, I would probably assume I had some kind of big blocking here, but I'm running this in isolation by myself. So there's definitely not any blocking going on. And the reason why I had this profiler catching this session is so that you can see the code in that function here. It's running for every single row we had in there. And so that's one of the reasons why inline functions are not a good thing for you to use. You know, as someone who was a developer before I became a data architect and performance tuner, I completely get. I used to use them myself before I knew because you kind of think object oriented. This is nice. You have an object, you can reuse it. But this is just something the optimizer struggles with and does not do very well at all, as we can see here. So let's go ahead and turn on this feature so we can see how that might change things for us. So I'm going to go ahead and turn this on. And so on Books Online with your function, there are a lot of requirements for scalar functions to even be eligible for inlining. In fact, it is so huge. Let me see here. I'm going to pull this over to the screen just so you guys can and ladies can see. There are so many requirements for this thing to go inline. Luckily for us, there's actually a column here on sysmodules that will tell you if your function is eligible for it. So we can easily see here that my function that I'm using is inlineable, so it should go through and end the row by row processing that we're seeing. So we're going to go ahead and run this now that it's enabled. Same exact code. So in this case here, we're not even changing anything with the code. We're hoping to get a great benefit from the fact that we're on SQL Server 2019. So let's see what happens here. So this is running. And you don't see the statements going for every single row here because it was able to be inlined, but we're still running. So we went from 15 seconds to 16. Not really much of any improvement. So let's go ahead and take a look and see why. So first thing that's going to jump out here, I'm looking at the IO here. And so we know already that there were 504 rows in our products table. So I can see here, we're scanning a work table here for every single row that was in this table. And because of that, we're doing an insane amount of logical reads. In fact, you look here, we have over 14 million for a database that's not that big. And we can see here, it really didn't do anything better performance-wise for us. So let's go look at the execution plan here. So the first thing that should jump out to you is this area here looks pretty familiar to what we saw before. In fact, before we turned on inlining UDFs, this was pretty much all you saw here. is this part here. But remember, we kind of talked about nested loop. And so the nice way I like to always think about a nested loop is kind of like a for each loop. For everything here, in our case here are 504 records. For every one of those, we're going to go here and do everything down underneath it here. And when we actually go all the way over here, we're going to see that we're scanning our very big table here. Every single time. So we're doing that. This is why we're doing the 504 scans across that whole table. So I wouldn't really call this an improvement. It's something you want to be careful and know exactly how inlining works, because it may or may not really help you. If you're working with a third-party app and you're not allowed to change the code, this might be an option you can use in a lot of cases to help you. In cases where it doesn't, you could throw in a query hint here. But since we're dev focused here today, we're going to figure out, we've noticed this problem that definitely doesn't perform well. How can we get the same results by doing something a little bit different? And so here, instead of using a scalar function, we're going to use what's known as a table function. And what this does here is it allows me to pass in a set of product IDs and filter based off of them. So let me go ahead and run that there so we have that. And so I'm going to get us our same starting point. And so what I'm going to do here is cross-apply with the function. So I have in the code here that goes in through a lot more details of exactly what goes on with cross-applying, but just to kind of show you is basically similar concept, except instead of doing one-by-one processing here, we're basically going to pass in our set here of product IDs into this function over here. And its output could be multiple columns. And here, for example, we're referencing one of those columns that comes out here. So let's take a look at this one here. And while this isn't sub-second, it's still a lot faster than using the scalar function with or without the new inlining in 2019. And so a couple other things to notice here. By going this route, it allowed us to go parallel and get benefits from actual parallel processing here with our data. So if we look at our IO here, 73,000, definitely a lot better than the 14 million we saw here, and 3 seconds a lot better than 15 seconds there. So in this case here, if you see a scalar function and you're able to change the code, one thing I strongly recommend is go ahead and try to see if you can flip that over to a table function and get some benefits from there.
So it sounds like despite 2019 feature for functions, inline function is probably still not a good idea.
If you can rewrite the code, still rewrite the code, definitely.
Okay. If you try to understand Microsoft logic, why would they keep that at all if this is usually bad?
So I'm making assumptions here, but I know that they've added telemetry to get a better understanding of how people use their product. And a lot of people, I suspect, use scalar functions, and they're trying to come up with scenarios where in a lot of cases, performance might be better.
Got it.
So again, if you can rewrite your code, rewrite your code. In fact, here I show you here how I'm using CrossApply in this example. Here, I'm just going to rewrite it another way and get the exact same results too here. Instead, I'm just doing a right join off that and doing a max up here and group by. So could be multiple ways to get to much better plans there.
I think we have a few questions, and
Yep.
Well, first of all, is somebody telling you thank you that learned something new today, and we're creating non-clustered index on sales large table would have helped in scalar inline function.
So good question. And we have an example where we're going to go through some cases where we seek on the user function there as well. In fact, if you want here, we could go ahead and play here. I have, steps here on how to make this even a little bit better. So for example, most people that have SQL Server 2016, if you have CU1, whether you're on Standard Edition or Enterprise, Standard Edition now allows you to compress data as well. So there was a white paper well back early, I think 2008, when data compression was focused on, that shows that even row level in almost all cases is a best practice there if you're able to use it. So it's one of those questions too that I tend to ask, if you were creating an index, what are some of the options you might include with that index and why? Like whether you want to do it online or compress data here. So here we have that index. I'm going to go ahead and do this now, and we're going to see that our IO should improve. So this is now right around sub-second. And so on this case here, we're not really doing filtering. I'm going to go over to showing the same feature with multi-statement inline function, where we're going to have that scenario here that someone mentioned in the chat about wondering if indexing can help, which we're going to go through here. So just like a scalar function, you can have multiple things going on inside of your function here. So here's an example where I want to look at my big table here, and I want to get the total amount of sales for a product. And then if this is a product, basically return a category based by how much the total is here. So if it's null or 0, then return null. If it's 500,000 regular or 1 million or higher, then go that route there. So we're going to go ahead and go through here, make sure that I have this function in here.
That looks like a lousy way of doing a lookup table.
No, agree. But it's you'll be shocked.
It's an example, yeah.
How many times I see code similar to this. In fact, this is kind of even an example on the link that I'll share in the PowerPoint for Books Online. This is kind of porting, similar things to one of their examples over towards the AdventureWorks database here. And so here, what I'm doing now is now we're adding a filter. So now I'm wanting to select and return what we get here, but also we're going to filter off that. So we only want categories that are platinum here. So basically products is a fancy way of saying, give me the products that sold for a total of over 1 million. So let's go ahead and run this. And yes, yeah, we'll have the links here and make sure that those are all included for you. If I at the end, I'll give you a link to my blog where we have the sample code and everything for you. But here, so this took about 2 seconds here. So let's take a look at that execution plan. So similar, even with our filtering here. So we're still kind of coming through here for every row on our products table. And over here, instead of scanning like we were, we're still seeking and needing, quite a bit of data. So it's still kind of a similar pattern over here. You got all kinds of other fun stuff here that's added. And because we're using it in our filter, guess what? We're doing it twice. So how could we do this, get the same result, but a little bit better? So this is an example where I'm going to use what I call a light CTE, perfectly fine CTE in this example here. And yes, that is a very ugly plan. So one of the things I notice with inline functions is it tends to get you pretty messy plans. And you're going to see a lot of cases where you're kind of in a way still doing this here. It's just, if you look at your plan, you see that you're taking your input here through our good old nested loop to the output over here and doing everything that it's needed there for that. So let's go ahead and we're going to take a look at how can we do this a little bit differently here. So our IO we can see was 40,000, took a little over 2 seconds. The other thing to note here too is you can see that we're not going parallel at all here as well. So that will kind of inhibit you and not allow you to go parallel over here. So let's go ahead here and I'm going to run this query. And so what we're doing first, you can see that ran about half the time, is I'm just saying, okay, get me the sum total here off of this table. And then I'm going to bring that in here and be able to filter and get my result there. And so here, we're able to have a much different plan. And you can see we're also able to go parallel here where we weren't able to before. So even though I'm scanning this one table to do this part, I'm making up so much more by how it pulls together the rest of the execution plan. So we had 40,000 for IO on our scalar UDF function there, where here we have half of it here. And same thing for our time. So depending on how often you run these statements, if it's an important query that runs frequently, this can be a huge, huge resource saver for you there. So hopefully that helps. I know there was a question in there about indexing and how indexing plays with this. So hopefully that helps answer that one. And that pattern. So at the end here, I'll come back to some more interesting information about scalar functions. In fact, here, we'll just go to it right now in the deck since it relates to this, and I'll pop back over to it at the end. Because there is something very important I do want to make sure everyone knows about scalar UDF inlining. It's been what I would classify a pretty buggy feature. And when I say buggy, every month or so, Microsoft release is a commutative update. You could see there's been a lot of updates for things that didn't go exactly as designed with scalar UDF functions. A lot of interesting stuff here. So the link here on this deck, which we'll make sure that you guys get as well, could take you straight to the page that kind of goes. They have a whole dedicated page about stuff that had to change and be fixed with inlining. So on top of that, it's one of the most, I would say, updated feature due to things finding out not going exactly as planned with it as well. So again, just to reiterate, if you have the ability to go through and change the code, I strongly recommend you change that to go over to a table function or rewrite your code to be more optimized instead of using a scalar function to begin with. All right, so going from here, we're going to go over to our next pattern here. And we're going to look at something that kind of changes a bit with 2017. And this is multi-statement table value functions. And so a multi-statement table value function, and there's kind of two different flavors of table functions. One here is our what's known as multi-statement, which basically allows you can do multiple things here. So instead of just a select statement here, in this case, I'm inserting and returning it. But if I wanted to, I could do more stuff in here. So just looking at this, I would think this is a pretty cool, great structured way to do this. I get to define kind of my table that's going to come back. I could do more things and put it in here. But let's go ahead and see how this performs for us. And I'm going to start off here with before 2017 compatibility. So we can see if you're using 2016 or anything before that, how this would work for you. So we have that there. I'm going to turn my statistics on here. And so I'm going to run a query here that's going to go ahead and take that table value function and use it as part of this aggregate that I'm going to do here. And so we're going to run this. It takes a few seconds. And so there's a couple things that I'm going to focus on by looking at this execution plan. So the very first thing is, so if you're not on SQL Server 2017 or greater, the first thing that's going to happen here is we're going to estimate amount of rows that's inside of your table function instead of actually going and looking. So here you can see here, we're estimating 100. Actually, if you go before 2016, it'll only estimate one row here. But in this case, we're estimating 100. And we're actually using 230,000, so 23 times the amount of data. And so why is this going to be a problem for us? Well, for a couple of reasons. One, remember, this is estimating only 100 rows, so nested loop seems super nice, but when you go through and do this 230,000 times and got to go back here, even though we're seeking and getting data, this gets to be pretty darn expensive here. On top of that, because we estimated 100 rows, we only got enough memory for sorting what we thought would be 100 rows here. So we have this exclamation point, and that's because we actually have to go to tempdb on this as well. So if I focus in on here, you're going to see this nice or not so nice warning here. That's going to showcase that, hey, you only had 1 MB of allocated memory granted for this query. So we're pumping in 200,000. We definitely need to go off the tempdb and have that happen there. So all kinds of not so fun stuff here because of this. So the other thing to notice here is kind of just like a scalar function, we're referencing and we can see the function here, but we don't see like the underlining tables inside of that function here. All right, we don't see our order lines, we don't see orders. All right, so let's see, what could we possibly do to make this be better? And so
John?
in this, yes.
Before that, there is a question, I think. Curious, how would the last CT example fare against using sum over partition by in the CT and simple where sum greater in the base query? Unfortunately, it basically takes you back to, I think, to previous.
Yeah, I mean, I'm going to go over, I think, an example too that kind of helps with that a little bit.
Perfect, thank you.
I think when I go through my running totals, it's similar to kind of where that is going. So yeah, let's go ahead and stay on this here. So here, instead of a multi-statement, I'm using an inline table function. So inline only allows you to do one select and you return it here. So with this actually is going to perform better for us. And this is just telling me I should have dropped it, or it's already there. And so now I'm running the exact same query. The only difference is I'm referencing the inline function instead of the multi-statement function here. And so when I run this here, instantly, right, so much quicker. So let's go ahead and take a look here at our difference here. So eyeball here, we had like maybe 200 reads, where up above here we had a lot more. We had about, I'd say, close to 1 million. So huge, huge difference there. And let's go look at this execution plan here. Oh, let me apologize. I meant to scroll over here. So on our scan here, we actually are going to have good stats. And because of that, that allows us to use a hash match over here instead of that nested loop here. So if I actually go highlight over here on that, so instead of our 100, I'm going to switch to green because this is definitely good here. We actually have very good stats, which allows us to not need to use tempdb for this query at all. Plus, you can see here, we actually have the tables because of it being inline table value function. We actually have those tables. So stock item is there and orders should be right there. So orders, and so we have those two. And when we go look at our plan here, instead of having 1 MB, we actually see proper amount of memory over here, which is definitely helpful here. So here I can see that there is 23 MB instead of the 1 MB before. So once again, if you see multi-statement table value functions and you're able to convert that to an inline, so you're going to see some good performance there on your older versions. So let's go ahead and look at what happens if we're on SQL Server 2019, right? This must be better, right? Because it's 2019 and everything gets better in newer versions. At least that's what marketing tells us all the time. So here, I'm going to do the same thing with that multi-statement table value function here. And we're going to see some good differences here. So remember, before we had only 100 rows in here for sample size, where here, oh, sorry, wrong one. This is what we're looking for here. We have good stats here. So instead of our 100 here, we actually have our 230,000 rows here, which allows us to do a hash match instead of that nested loop. And we actually have proper memory here. So similar to before, we have our multi-statement function here instead of directly seeing our tables. But this definitely is an improvement here. So we went from about 1 million to here 500 reads or so in about a half second here. So once again, I'm going to run our same query, but using inline just to see how is this different with 2019. And it runs instantly. I mean, our IO is a little bit lower, our time is faster. So let's go see and look how this changed. And so the big change here, which may be shocking to a lot of people here if you've never seen an adaptive join, but typically with all scans or seeks, you see 2 coming in and 1 coming out, right? You typically will see something like this and something coming out. Like same thing we're seeing here with this hash match up here. We have 1 coming in, another 1 coming in, and 1 coming out. Well, here, this is very interesting because with our adaptive join here, this is like a hybrid join where based on the amount of data that you're picking in, it's actually going to change between a hash and a nested loop here. And so this is there, which in our case, and you're probably going to want to know then, well, how do you know which one's going to be used? And the way how you can tell here is based on statistics for the execution plan, you're going to have a threshold here. And so if you have more rows than this threshold here, then you're going to go over to a hash, which we see here. If we actually had lower here, this would go ahead and do the nested loop there, lookup there. So this is even better and allows us to have that adaptive join there as well. So once again, I think this is a better use case of if you have multi-statement table value functions, performance can get better, but I still think you're probably going to get better performance if you're able to convert that over to an inline table value function. Right. So yeah, the other key thing to note there is what basically at a high level this allows you to do is typically when you build an execution plan, it has the stats and it builds everything from there. What kind of happens here when we go look, just to make sure this is very clear for everyone, is with the new functionality, this is kind of breaking the way we knew execution plans being built happened. It starts to go ahead, build the plan, but it persists and gets real stats for that table value function first. That's what allows us to actually have good stats over here instead of the original of only having 100 here. So it does that. It does this part first before it actually goes through and does everything else. And that's why we're able to do the hash match there. So with that, we're going to now go into table variables versus temp tables. So I'm going to go ahead and set this up, and we're going to go back to what I would call older mode here. So this is before we had some changes in the optimizer that were built towards this pattern. And so what I'm doing here, I'm going to start from our cold spot here, of assuming nothing's in memory. And we're going to look at table variables first. And there's tons of myths about table variables versus temp tables. For example, one I see all the time is, well, you can't have any indexing on table variables. Well, watch what I'm doing here. I'm creating a primary cluster key to index off of it. Also, you know, if you do a table variable, it won't go into tempdb ever. Also not always true here. So here I'm going to run this. So we could take our first look here. And so we're really only focused on the bottom part here. So let me scroll that up here. And so this is just like what we saw. So I switched the compatibility mode to 2014 just to show you here that if you're on 16, it'll assume 100. So this is the same thing as the multi-statement table value functions that we saw here. So this is definitely not ideal, where we're assuming one row and going for 1,000 here. So another thing that's a myth here is that you can't get statistics for your table variables. Well, if you really want statistics, you can get them if you add option recompile, which basically will end up recompiling, building a new execution plan every time this query runs. So here we go. We have statistics. But the interesting thing that you're going to notice is it doesn't really drive any changes with how we're joining to the rest of our data here. Where if I go ahead and go to a temp table here, this will. So this here converts over to a merge and gets you better performance as well over here. So one thing I tend to refer to, if you don't know how much data is going to go into your input here, when I say input, your temp table or your table variable, you definitely don't want to use table variables because you want to keep those for very low counts here. Where a temp table here tends to perform better when you're going to be pumping in more data or you have an unknown amount of data. But let's go ahead and see, does this change with 2019? So we have table variable deferred computation, which is similar to where we're going to get actually real good stats and pause there before we actually build our plan. And let's see, how does this plan change or maybe not change depending on what we had on our temp table here. So I'm going to go ahead and run this. We're going to go ahead and do our worst case scenario over here. And then I'm going to go ahead and rerun that table variable over here. And so the big thing I want to drive home here is we get the same execution plan here. So this is definitely a good thing. This is definitely helping out here and kind of giving you similar performance with temp tables. So just like all the other new IQP features here, you can turn them off at a database level. So here I'm just turning it off, turning it back on to show you here that you could do that here for this. And then here, if we run the same query, there's also a query level hint here that we can use to disable it as well. So from here in this example, we're going to go away from that merge join and go back to a hash join over there. All right. All right, so with that, we're going to go into CTEs and what I call abusing CTEs. And when I say abusing CTEs, what I see a lot too is people will nest CTEs, and a lot of times I see it done to kind of get a more pretty final query, but it ends up not being as well performant as doing this in different ways. And we're going to go through an example of that. So first, we've already used CTEs a little bit in here. So you know that by itself, a CTE isn't horrible, right? That sometimes you might read or see people say that, but it's really how you use it. And so here's to show you a nice simple example of basically going through to get an average here of totals here, where this query here isn't any different than the one below it. So if I look at the execution plan of these two running, exactly the same. So nothing really bad with these. Now, when I see CTEs go bad is when they're nested, and particularly nested for reasons that might not be really needed at all. So here's kind of a perfect example building off of that last question that you saw. So here we're going through and we're getting our averages for orders 2017 or later. We're taking that input. We're going to the next. So this is why you could see it's nested, because here's our first one, and then here we break off to go into another. And so really here, we're just going off of sales quota here to go ahead and do some basic math here. If it's null, give 0, and then join back here. And then we're going into another one here to do the averages here. And then finally here, we're going back to our basic query. And so this kind of pattern I see a lot. And the first thing that's going to show up when you run this is it's going to have a huge execution plan that's very, very hard to understand. So even though this ran in 4 seconds, when we go look at our execution plan, you can see this thing is sprawled all over the place here. And it's kind of very hard to understand, okay, what is for which CTE and how is this all nest back together? And whenever you have bigger plans like this, it makes it a lot harder on the optimizer too to help you get a really good plan over here. So let's see if we split this up into separate components even, we're going to see some benefits here. So here I'm going through using table variables. And just breaking those pieces. I mean, you could still optimize this even more. I'm just showcasing the difference by making this one small change here from our 4 seconds here. And looking at the IO here. I mean, well in the 100,000 range. So if I run this, first of all, breaking this into separate places makes this very easy for you to understand. For example, looking here, we can see if we need to make changes to improve, we want to focus on the top part here, which is pretty straightforward breaking down compared to the other parts here. So this is one area to where if you're nesting CTEs, probably want to really look and understand why are you really nesting them, because in a lot of cases it's probably not necessary. And if so, see if you can maybe break them up into smaller pieces as well. I have the same thing here in TempDB. I'll save that for you guys to go through if you want to, and you guys, if you guys go through this later. And so with that, we'll go ahead and head over to our next example here. So in this next example here, what I'm doing here, and I see this common, is I'm doing a count just really to see if something exists. And so in this case here, I have to scan across this. And, you know, I'm making this as simple as possible. This is not print records exist. This is usually do a whole bunch of other stuff, right? But just trying to simplify this down here. So we're scanning across our whole table. So one thing you might be thinking is, well, what if I just do, you know, top one here from the count? And so same thing here. So what you could do differently here is use if exists. So the nice thing about this is it's a terminating operator to where it will stop this the first time it satisfies this exist part here. So as we run this here, we can see even though we're supposed to scan, it was able to terminate after finding its first occasion of this happening here. So if it exists, this is potential for you to do a lot less I/O, even if you have a scan there in your plan. All right. So hopefully everyone's still with me there. We're going to go ahead and go over now into implicit conversions. And so this is also common. So implicit conversions basically happen when you have mismatching data types here that you're using on filters. So here I'm just going to go ahead and look and say, okay, what are the indexes that exist over here? And so the main reason why I'm doing this, and as I zoom in, we can see our clustered index here has two columns. So the first one here is sales order ID. And the second one, in this case here, I'm just going to make this red, is order ID details. So it's a composite clustered index. It's on multiple columns. So the reason why I highlighted them this way is because if you're doing filters and you filter just on this guy here, you're going to scan, where if you're only going on this guy because he's first, it'll go through and seek there. So in this case, the reason why we're showing this here is to say, we know we got an index here, our clustered index here. So we should be able to seek, because this is our clustered index. We don't have to look up any data if we have columns here that aren't in our filter, because the clustered index includes every single column. But what we're doing here, and if we look, we can see this is an integer data type here. So here we have our column that we're going to filter on as an int. But here I'm showing a case which I see this a lot, especially with ORMs as a perfect example. But we're actually doing something not so good here. We're actually thinking it's a string and doing a like on this. So because of this, we're going to actually go through over here and scan. So scanning, meaning that we're going across every single row here in our table. As the table gets better, this gets worse. Doing this correctly here, this is going to go ahead, integer on both sides. We're going to seek just as expected here. And so we're doing 3 logical reads over here instead of the whole table, which we had up here. So 1,000 and 1,240 versus 3 on there. So the interesting thing I just want to show you is, and I did this a little earlier in an example, but sometimes SQL Server will still try to even save you. So in this case here, even though we on this side here, we have a character string, with our equal sign here, when we run this, we're still seeking. And the reason why is if you look into the details here, the optimizer is actually saving you by converting this on the predicate side for you without you even telling it to do it. So yeah, once again, be very careful with data types, especially if you're using ORMs. And so we have that there. And then our next one here, we're going to go.
John, I think there is a question for you.
Okay.
So implicit conversion causes performance issues, where explicit conversions does not. I think this is right.
Yes.
And another one, I think, whoever was asking this question didn't like your example, saying that the other was different.
Well, let's hold this off for the very end.
Okay, sure.
Yeah, let's definitely save that there, because we have one more example which I think kind of goes, if this is what I was thinking, it goes more into that might help you, because we have two more patterns here before we end our session here. So this one is what I call kind of the kitchen sink reporting query. Hopefully you don't see this one, but I tend to see this one all the time. And so just in doing some cleanup in case we have procedures here. And so I still even simplified this a little bit. For example, create procedure. Here's a bunch of things we might filter on. Notice I have default equaling null here. And this could keep going on forever and ever and ever. And so what I tend to see here is a pattern like this, where we're doing a lot of joins for parameters that may never even come into play here. So for example here, we're using coalesce. Again, we already kind of saw in a previous example, this probably is not your best way you want to do this here if you want to seek or be eligible for seeking. But this is an example where we're taking our parameter and we're looking to see if our parameter exists. Great, let's use it. If not, well, then let's go ahead and do what the column is there. So we can kind of see that across the board here. And you can also see that we're joining to some tables here that might even be not necessary, but they're really just here in case we're going to be filtering as well. So let's go ahead and get this going so we could show this. And so what I'm going to do is I'm going to run, so I just freed out execution plan, so I have nothing here for the stored procedure, and I'm going to run it with only using the last name here as a filter. And so this will run. So it runs, takes about 4 seconds, returns 12,000 rows. Does a good amount of I/O here. So let's take a look at the execution plan. And so a nice thing with stored procedures is that you'll see here, they try to help you out by building the plan based off of the first time they're run. So a lot of people always think with execution plans, you only focus from right to left, which isn't always the case. Because here's a perfect example of when I go through and select here, I can actually look at my parameter list and see what was used here. So because this is the first time I ran it, our values are going to match up here. But if I run this again with any other parameters, our runtime are probably going to be different unless it was the exact same parameter used here. So even though here we have, looks like we're spilling over into temp B over here, and we're doing scans here because of all these coalesces in here. Let's go ahead and look at a more filtered use case here. So here we're filtering on ship date, and we're also going off customer ID as well. And so while this runs quicker, notice we still have our big scan here, and our execution plan is still the same. And the reason why is because we're using the plan that was built for our first run here. So once again, just to kind of highlight that, if we go over here and we go look at ship date, this was null originally, and now we actually have parameters for it here. Same thing here for customer ID. And if we were to look over here at customer last name, this had a value, and now we're passing in null as well. So we're still working off that one execution plan. So this is where dynamic SQL, if done correctly, can actually be helpful for you. And so here we're going to show you why. So let me go ahead and create this stored procedure. And then before we run it, we'll go ahead and take a look at what's happening in here. So the first thing I love to do with any type of dynamic SQL is start off with a comment. That's very helpful for letting me know where the SQL statement is in case I ever have to go find it and go tweak it for any reasons. So that's why I always start off with a comment in here. Typically, like in this case here, probably be the name of the stored procedure as an example. But I'm breaking this up into parts here. So I have my select here, and then I'm using my joins here for where I need them. So for example, there's some extra tables here that are really included just in case a filter is needed for those tables here. So that way, if it's needed, they'll be included. So if customer last name is included, well, then let's go ahead and include what we need to be able to go ahead and get that data. And then I start building my filter the same way over here. And so I have my parameters over here. And then the key important thing, so print here, this will show me, I just have this for testing so I can see what SQL was generated here when this runs. But the key thing here also is to use SP execute SQL because this will do a couple of things for us. One, it keeps your code parameterized, which will help you with SQL injection. But also what a lot of people don't know is when you pass your parameter list here, you actually don't have to use all the parameters. So for example, you can run this with different parameters here based on your statement that's needed in there. So let's go ahead and take that. And with the parameters that you use, if you use different parameters, it could get you different execution plans as well. So let's go ahead and we're going to run this now, the same two. And we'll see that in this example, not one, but both execution plans are very different because we're only going after exactly what we need in here. And so both of these are sub-second. This originally took 4 seconds. And so here we're going to see this one be even a lot smaller because remember up here that we had an extra join over here that we were using if we needed to go off of the customer name here. So let's go ahead and run this. So same stored procedure, but because of the execute SQL and the different parameters there, it's going to build one plan for each set of parameters that you have there. So that's one way to kind of definitely help you in those scenarios where you have a whole lot of potential filters that may or may not be used. And you want to kind of account for as many of those as you possibly can. This is kind of like a great dashboard scenario where you might have like a filter grid up top where people could pick things, and based off of that, you're going to go ahead and filter, the little dashboard result set that you see. So this is just showing you another way, which I hope you don't do it, because this allows you to be open for SQL injection, where if anyone could get to your parameter, they can change it and add SQL in there. It looks pretty similar, but we're kind of concatenating the values in here. And we're using execute SQL as well over here. So similar thing there. So when I ran this here, just to kind of show you, here's that select statement. So if I had, like extended event running and, I had this statement, having this part here would be very helpful to go back and say, okay, I know where this came from, where without that could be a lot harder to try to track down. All right, so our last example here is a common one I especially see in scenarios where you want running totals. So here, I'm going to go ahead and I'm going to listen to the notes I put here. So it says go ahead and do estimated instead of actual because this is going to take a lot longer. So here's kind of just setting this up to show you what we're really wanting to do here. So in this scenario, we want to take every transaction that we have and basically add them together. So this is just showing you what the transactions look like. But, if we were focusing on this record, we want to add these two together. If we want to focus on this record, we want to add all of it together and kind of keep that pattern going. That's what I call by running totals here. So I'm going to show you one of the ways this is done. It was done, in what I would call an older school way. But if you join to the table twice here and you do greater or equal like this can actually give you the result that you're wanting here. So estimate here, we can see we're seeking twice, nested loop, all kinds of fun stuff here. This query is going to take a bit to go through here. We can see it's starting to return results and it's kind of cranking through there. And you can see here how this added together will get you that one and you know, adding them there. This gives you a result that you want, but it's definitely not one of the more efficient ways to do this. So I think this probably goes, yeah, there about 25 seconds, 14,000 rows, and a whole lot of IO with it as well, and a lot of scans going through there. All right, so what's a different way of doing this? One, which was an improvement on older versions of SQL Server, actually could have been to use a cursor. So a lot of DBAs always say never use a cursor. Well, this is just highlighting to show you an example where doing so will get you some better performance with this pattern here, because as we're going through this table part once, especially if you use fast forward only and static, those are things that you might want to add if you have a cursor there just to help you pull data from a select. While we're fetching here, we can kind of go through and update the total and do this for you and then get the result. So kind of a lot more code in here to do this, but we'll see that this goes a lot faster than the 30 seconds or so it took to just join the two tables together. So in fact, we already got down to 4 this way. All right, logical reads. Of course, you're going to have to sum this all up across the board if you want to know the total. But there's a better way of doing this starting with 2012. So hopefully everyone's on at least 2012. And here you can use what's known as Windows functions here. So what this is going to allow us to do is as we're going through by transaction ID, we're actually going to sum it up as we go along here. So if I run this here, instantly, and you can see here by looking at this, I'll kind of zoom in on this. So our first part of this, just to kind of focus on here, is we're ordering here by transaction ID and then summing as we go along here. So basically looking at our first example here, we have nothing there to sum it against, so it's just itself. Our next record here is going to be these two added together, while this one here is going to be those, and so forth, keep going down. If we look at our execution plan, we're going to see this window spool, and this is what's allowing us to do that sum as we're going. It's actually pulling back and looking at previous records in order to do that there. And so from this execution, I mean, we're sub-second here. It took 300 milliseconds and only 80,000 reads. So a lot more efficient there for that example. So, alrighty, that concludes a lot of our patterns here. Let me go ahead and run back through those last few slides again. So I just want to refocus on UDF inlining with new feature set. This is kind of one I'm a little more skittish about just because of a lot of the changes that have happened. So if you are planning on using scalar functions, definitely make sure you're on the newest CU. Because if you look here, 12, which was just released a little while ago, is the first one in a series here of not actually having something explicitly improving inlining functions. So yeah, there's been a lot there. And this is just kind of showing you back to examples. It gets even real scary if you use an inline scalar function inside of a scalar line function, which is kind of pointed out there as well. So once again, here's all my contact information. Like I said, if you go out to johnsterrett.com there, you'll see that my blog is there and that I have this presentation here. I'll make sure to send a copy over to Steve as well for anybody that wants all of the sample code that you can go through it. And if you do and you have any questions about making your code go faster, definitely let me know. Feel free to reach out. I love working to make queries go faster. I'm active on Twitter. You can hit me an email or LinkedIn. But yeah, hopefully this showed a lot of ways on how you can rewrite code a little bit different to help improve it, and also get some good understanding on how 17 and 19 can help in cases improve your code as well. And with that, Steve, I'll go ahead and turn it back over to you.
Sure, thank you, but you have a few more questions.
Okay.
I guess the easiest one is the parameter sniffing issue will be present on the SSRS reports. I think it depends on the procedure, right?
So will the parameter sniffing? Yes. So this, I mean, you'd have the same thing. If this is calling a stored procedure, just like we're doing here, you're going to have the same scenario here. Anytime you run a stored procedure, regardless of it being reporting services, a .NET application or anything else, the first time you run that stored procedure, as long as the plan stays in cache, you're going to have that parameter sniffing. The reason why this helps a bit is because with SP execute SQL, you're going to get a different plan for each set of parameters you actually use in here. So hopefully that's answers that question.
All IKPU related features that are introduced in SQL Server 2019 are disabled by default.
No. If you are on compatibility mode for 2015, they'll be enabled by default. So like the ones we went over with scalar functions, the inlining, all those there will be enabled by default.
Okay, so got it. Okay.
Yeah, so remember, this is a case, so whenever I do upgrades, what I strongly encourage is actually testing and validating that your code actually gives you same or better performance. Because remember, I showed you two different ways on how you can, if you need to disable, I showed you two different ways on how you could do it, one at the query level and one for the whole database itself.
Yeah, through the hint or through the altering the database.
Yeah, so a lot of people by default, what they'll end up doing is just go straight and change the compatibility mode all the way back to the previous version. The nice thing here is you don't have to do that. You can just kind of disable these one by one if they're a pain for you, or do it just only at the query level.
What about disable parameter sniffing hint or option recompile?
So, I mean, option recompile, that will rebuild your execution plan every single time. This is one of those kind of it depends, and I would want to see or know more about how this stored procedure is getting executed, because there's CPU resources that are required every single time you build an execution plan. So if this is something that runs, thousands or hundreds of thousands of times a minute, I probably would be a little more skittish in wanting to do that. But this is kind of one of those it depends. I would need to see and know more.
And any chance if you can go back to the question about the group by?
Where is that in here?
It was 20 minutes ago. Your recent example was not related to my question.
Okay.
Cool.
I think I got it there.
Perfect.
Had a CTE with a group by returning IDs and some in the base query joining back on the ID and filtering on some. Okay, I was asking why not use windowing some to return all the detailed columns needed from the CTE and filter on some output based by joining back here. Okay, that's a lot there. Not sure I'm fully understanding everything.
That being said, I think that attendee is saying that an example was like an hour ago. So I think this is good.
Okay.
Just ask.
All right. Any others in there? Or do you think we covered them all? Yeah, I'm scrolling through and I think we do. I think someone here mentioned Plan Explorer, which yes, definitely a great tool. Gives you a lot of insight into execution plans. I mean, one can do a session by that itself. Little time consuming to go through demo a whole bunch of scripts with it, but it gives you a lot of great information. Yeah, no, that's the tool I use all the time. And yes, it is free. They don't even ask you for your email address. Double check here, but I think we got the rest of them, Steve.
I think so too.
All righty. Well, thank you everyone for joining us.
Oh, wait a second. There's still a question about the IQP.
Oh, did something new pop in? Or did I miss it?
I think you kind of answered that. Again, the question is about the features of SQL Server 2019, if they are enabled or if they are disabled by default. And I'm talking about new features.
Yeah, so that is going to be based on your database compatibility for your database. So if you are on 115, or I'm sorry, 150, then they will be enabled by default. There also is a DMV that you can reference that will explicitly tell you which ones are enabled at the database level. So yeah, I could try to see if I can pull and find that here. It's probably a good thing to add into the session as well.
I didn't know that coalesce and is now are that different on the performance. I knew that the functionality is different, but I didn't know the performance is different.
Yeah. No, you're not alone there.
Your session so far was with most attendees. At some point, I saw 50.
Okay, awesome. Awesome. Yeah, like I said, I hope it was helpful for everyone. I'm definitely throwing more links in there for everyone here.
And your code and slide deck, there may be on your blog or GitHub.
Yes. Yeah, let me get that also. Direct link for that stuff.
John, thanks for the session.
Thank you very much.
And attendees, thanks for attending August 2021 Los Angeles Data Platform meeting.
Thank you.
Thank you. Good night.